Good morning, everyone. This is Shilpa, an assistant professor from the Department of Mathematics. Today, I'm going to discuss about the hypothesis testing. First of all, what is this hypothesis testing? So many of us have an idea of what is meant by hypothesis testing. So usually we use this hypothesis testing in statistics. So whenever we have any assumption, so whether our assumption is correct or wrong, how much percentage it is true, so how much confidence we are correct, so all those things can be discussed through the hypothesis testing. So this video I'm making the content regarding for the exam point of view, so I hope this video will be some useful for you all. Coming to the hypothesis testing, before discussing about the hypothesis testing, we'll see what is the meaning of population, sample. Okay, population means in statistics, the word population deals us with so population is denoted with capital N, and a part of population is called as sample. For example, if we want to discuss anything about the students' marks, so if you want to know the average of the marks, so from that average of the marks, we take a part of the sample from that marks, that's called as a sample. So sample denoted with small n. Sample is of two types. Large sample and small sample. So large sample, it is n greater than or equal to 30, and small sample n less than 30. So coming to the steps of hypothesis testing. So step 1. So here in this steps of hypothesis testing, we have 5 steps. Step 1. Null hypothesis H0. Step 2. Alternative hypothesis H1. Step 3. Level of significance alpha. Step 4. Test statistic. Step 5. Conclusion. So the complete unit of this hypothesis testing revolves around these 5 steps. The first step, null hypothesis H0. Second step, alternative hypothesis H1. Step 3, level of significance alpha. Step 4, test statistic. And step 5, conclusion. So these definitions, null hypothesis definitions are important for your 1 mark questions. Null hypothesis, alternative hypothesis, level of significance alpha, critical region, type 1 and type 2 errors, and next degrees of freedom. So these are some definitions in this unit that are useful for your 1 mark questions. Okay, null hypothesis, all as it is denoted with H0. So here this unit is divided into, we'll divide into 2 parts. Samples based upon your sample size. So I'm dividing the unit into 2 parts. The first part is about large sample. The second part is about small sample. So large sample, as we know, n is greater than or equal to 30. Small sample, n less than 30. So here in large sample, we have totally 4 tests. So whenever we have a sample, So that sample can be categorized into two parts, large and small. So based upon this large and sample, we have to divide the problem. So first we need to read the problem, then we have to analyze what problem it is, whether it is a large sample problem or a small sample problem. After analyzing it, then we have to come which test we have to use depending upon the given data. So the first one, large sample. So in large sample, we have two tests, Z test and proportion test. So again Z test, two models, single mean and difference of means. Similarly, proportion also, single proportion and difference of proportion. Again in small samples we have three tests, T test, F test and chi-square test. So this is a small picture of what we have in this unit, large sample and small sample. So large sample we have two models, Z test and proportion. In small we have T test, F test and chi-square. Again the T test can be characterized into three parts, single mean, paired mean and difference of means. So as of now we will discuss with the Z test. So now here all the students will be having a doubt of when to use which test. So first of all so how to identify which test? So you can categorize into some few steps. The first step, read the problem completely. Second step, identify the sample size. Third step, how many samples are given? Fourth step, if samples are not given, then what type of data is given? So these are some few steps that we can identify from the problem and identify which test we have to use. So first step, read the problem carefully. Second, identify the sample size, that is small n value. Next, how many samples are given, whether one sample or two samples are given. Next, fourth step, so if samples mean are not given, then what type of data is given in the problem? So this, if you identify these four steps in your problem, then you can characterize or you can categorize the problem is of which model. For example, I have read the problem and I have seen that my sample is large sample. So as I said, again in large sample we have two categories, Z test and proportion. So coming to the first step, step 1, null hypothesis H0. So in Z test, if I have large sample of single sample, that means only one sample n, then in such case Z test and proportion. Here the null hypothesis, you can directly write it as mu equal to mu naught. Mu equal to mu naught. And here also you can write proportion. Proportion means nothing but ratio. So ratio means what? Area. So in that area, what is the strength of ladies and what is the strength of gents? So that can be characterized into a ratio. So whenever we talk about the ratio, in your mind, you should have proportion test. Whenever we talk about the mean and if it is a large sample, you should have in mind Z test. So mu equal to mu naught and proportion means P equal to P naught. Step 2, alternative hypothesis H1, mu not equal to mu naught or mu greater than mu naught or mu less than mu naught. So depending upon the problem, you can use any of these three notations. Whereas coming to the proportions, P not equal to P naught, P greater than P naught, P less than P naught. So when you have mu not equal to mu naught, it is called as two-tailed test. And when you have mu greater than mu naught or mu less than mu naught, it's called as one-tailed test. Similarly, for P not equal to P naught, it is called as two-tailed. These points need to be mentioned in the problem. So the accuracy you mention in the problem, that many marks you can secure in the exam. And P greater than P naught or P less than P naught, it is called as one-tailed test. So these are the two steps. Next, step 3, level of significance alpha. So this level of significance alpha, if it is not mentioned in the problem, then you consider it as 5%. So these are the first 3 steps. If you write these first 3 steps, at least you will get a few marks for this topic. So first step again, once again, step 1, null hypothesis H naught, mu equal to mu naught. Step 2, depending on the problem. So you will be having a doubt when to use which tail. So in the problem, if you have some keywords, inferior, superior, greater or lesser, then only go for one tail. If not, the problem will be depending on the two-tail test. Even for the proportion also, majority, minority, such type of things if are mentioned, then go for one tail. If not, go with the two-tail test. So level of significance not mentioned in the problem, consider it as 5%. So now comes the step 4, test statistic. So in this test statistic, when you go for a single mean of Z, Z equal to X bar minus mu by sigma by root n. This is the formula where X bar is mean of sample, mu is mean of population, sigma is standard deviation of population, and n is size of sample. So these are the things that are required in the formula. So next, step 5, conclusion. Here we use the critical value. This value for the last samples, you need to mesmerize the values that are given in your notes or textbook. You will be available with the table. There you have 5%, 10%, 1%. Those values you need to remember. These values will not be given in your final exam. So critical value. So depending upon the critical value, we categorize whether we have to accept or reject the null hypothesis H naught. And coming to the test statistic of proportion, Z equal to small p minus capital P by square root of PQ by N. Here Q equal to 1 minus capital P. Here small p denotes proportion of sample Capital P denotes proportion of population, and N denotes size of sample. As I mentioned, Q equal to 1 minus capital P. So these are the things that you need to remember when you go for Z test and proportion test. So critical value. After writing this critical value, here we are going to write the tabulated value that are given in your table. Then here, after writing this, then here we compare the calculated value and the tabulated value. So usually you can go in any way, but one thing you can remember, if you remember in this way, it will be easy for you. Calculated value on the left hand side and tabulated value on the right hand side. Make a habit of writing in this way. Calculated on the left hand side and tabulated on the right hand side. If calculated is less than tabulated, then we accept null hypothesis, and if calculated is greater than tabulated, we reject null hypothesis. So again I'm telling you, calculated value on the left hand side, tabulated value on the right hand side. So if calculated is less than tabulated, then we are going to accept it. If calculated is greater than tabulated, we are going to reject it. So this is a description of large sample with a single mean and single proportion. Whenever you have a single sample, this is the way you have to solve the problem. Next, when you have large sample and you have two samples, then the problem can be characterized into Z test or proportion test. Again, step 1, null hypothesis H naught. So how many samples we have? We have two samples here, N1 and N2. So null hypothesis H naught. So when we go with the null hypothesis H naught, as we have two samples, here you are going to write mu1 equal to mu2. Next, step 2. And here when we come with the proportion, P1 equal to P2. And next, step 2, alternative hypothesis H1, mu1 not equal to mu2, and proportion P1 not equal to P2. So usually most of the cases we get mu1 not equal to mu2. That is a two-tailed test. So in some rare cases we get of mu1 greater than mu2 or mu1 less than mu2, and here same, P1 greater than P2 or P1 less than P2. Next, coming to the step 3. So step 3, level of significance alpha, if not mentioned in the problem, we will consider it as 5% in both the cases, whether it may be a Z test or proportion test. Next, coming to the test statistic, Z equal to x bar minus y bar square root of sigma 1 square by n1 plus sigma 2 square by n2. Here Z equal to P1 minus P2 by square root of PQ into 1 by n1 plus 1 by n2. Once again, I'll repeat the steps here. Step 1, mu1 equal to mu naught because we have two samples here, and P1 equal to P2. Step 2, alternative hypothesis, either mu1 not equal to mu2 or P1 not equal to P2. Level of significance, if not mentioned, we consider it as 5%, or if it is mentioned according to the given problem, we consider that value. Next, step 4, test statistic, Z equal to x bar minus y bar by square root of sigma 1 square by n1 plus sigma 2 square by n2, and coming to the proportion, it is z equal to p1 minus p2 by square root of pq into 1 by n1 plus 1 by n2. These formulas will change according to the given data, but these are the standard formulas. And coming to the conclusion part, so the same thing will be concluded. Critical value you are going to tabulate by using the tables, and if calculated is less than tabulated, then we accept the null hypothesis, and if calculated is greater than tabulated, we reject the null hypothesis. So here, as we are categorizing into depending upon the samples, first we have categorized into large sample, then we are discussing whether it is a mean problem or a proportion problem. Again, we have categorized into one sample or two samples. When we go with the one sample, we are applying z test. When we are going with the proportion or ratio, it's called as proportion. We are using the proportion test. So this is how we are going to categorize, or this is how we are going to solve the problem depending upon the data. So this is completely about the large sample.
Like, share and subscribe. Hit the bell icon for more updates.